శుభోదయం అందరికీ నమస్కారములు. శ్రీ గురుభ్యో నమః. Today we are going to have a revision of Vedic mathematics, a class which is requested by many of all of us. Goutham ji will be entering. I think is logging in now. Now meanwhile we will start with Vande Mataram and Prarthana. And after that, we will see what is the situation. So let us request Kalla Chitbabu garu to recite Vande Mataram. Your video?
Yeah. My video is on.
Yes.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malayaj Sitalam, Sasya Syamalam Mataram, Vande Mataram. Subrajyosna pulakitaya
Kusumita Pramadala Sobhini
Suhasini Sumadurabhashini Sukadam Varadam Mataram Vande Mataram Vande Mataram.
Vande Mataram. I think his video got stuck, something like that. Now let us request Satyaji to chant Prarthana.
Namaskaram. Let's do meditation for a minute. Gananam tva Ganapatigum Havamahe Kavim Kavinam Upamasravastamam Jeshtarajam Brahmanam Brahmanaspata Anasrunvannotibhis Sida Sadhanam. Om Shri Mahaganadhipataye Namaha. Om Prano Devi Saraswati Vajebhirvajinivati Dhinam Avitriyavatu. Om Shri Mahasaraswatyai Namaha. Gurureva Gati Gurumeva Bhaje Gurunaiva Sahasmi Namo Gurave. Na Guroh Paramam Shishurasmi Guroh Matirasti Gurau Mama Pahi Guru. Jnananandamayam Devam निर्मलस्फटिकाकृतिम् आधारं सर्वविद्यानां हयग्रीवमुपास्महे श्रुतिस्मृतिपुराणानाम् आलयं करुणालयं नमामि भगवत्पाद शङ्करं लोकशङ्करं शङ्करं शङ्कराचार्यं केशवं बादरायणं सूत्रभाष्यकृतो वन्दे भगवन्तौ पुनः पुनः ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमवद्व्याप्तदेहाय दक्षिणामूर्तये नमः असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतं गमय ॐ शान्ति शान्ति शान्तिः मातृदेवो भव पितृदेवो भव आचार्यदेवो भव अतिथिदेवो भव सहनावतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः ॐ श्री गुरुभ्यो नमः हरिः ॐ
బాబు గారు మీరు మ్యూట్ లో ఉన్నారు.
ధన్యవాదములండి గారు. Now let us request Goutham ji to start his webinar, or in fact, clarification of the doubts, the participation from all of you. Mostly you will be speaking and he will be clarifying. So, Namaste Goutham ji.
Namaskar. Namaskar.
How are you going to take up this webinar?
I'll start this anyway. Start the presentation.
Okay.
And thereafter, let's see.
In fact, I kept everybody. they can unmute and
Right. So all yours. Yeah. Are you getting it?
Yes, we can see.
I got some questions that someone has doubt in this hexadecimal. Hexadecimal is not in this course. I just started, as I am preparing also for the advanced courses, I am completing my presentations on this hexadecimal. I just mentioned it, that's all, that time. So these are part of advanced. Anyway, you have to practice the hexadecimal, first the even simple addition, subtraction, and so on. Then only you will be here. Hexadecimal is not for this exactly, for this. We just wanted to show that this hexadecimal is also, Vedic mathematics is also applicable to hexadecimal. Someone has doubt regarding the multiplex oscillator things, divisibility using multiplex oscillator. So there are factors like this. Suppose somebody wants to know that what will be divisibility by 2,333. So if we multiply that by, if you see here, if we multiply that thing by, if we multiply by 3, it becomes 6,999, which is close to 7,000. And 7,000, it becomes third order oscillator becomes 7, and therefore you have to group in groups of 3. Groups of 3, the number of 9s or number of zeros that comes. So groups of 3, and then you apply the oscillation process. That is the thing. So please tell me your doubts. I'll start from the beginning.
Did you get any doubts through directly? Did you get any? Otherwise, I will ask. I will start asking some questions. Then,
Yeah.
that can be frequently missed questions by. Question number 314. While dividing 1, 2, 3, 4, 5 by 78 using Nikilam method, start the processing by separating the quotient and remainder with a line as. This is a very simple question. I don't know why people could not answer.
Which one? While?
314. Should I project that 314?
314 is the pin number.
No.
Oh, acha.
Yeah, what is it? 314?
314 is the question number. I will project it otherwise. Or I'll read it out again.
Okay.
Anybody else has a question, that is also welcome. Okay, while dividing 1, 2, 3, 4, 5 by 78.
Oh, 1, 2, 3, 4, 5, 78.
Yeah, using Nikilam method. How do you start the process?
1, 2,
3, 4, 5.
4, 5 by 78.
77, 8.
78 or 778?
Only 7, 8. Only two numbers.
78. See, first of all, you have to see what is the difference between.
No, shall we ask the participants how many don't know the answer for this? Instead of repeating, if people put their hands, then we will start explaining.
Yeah.
Otherwise, we'll go to another question. Oh, there are some people. How many?
First of all, how to start?
Only 2. Okay. At least for these 2 we will have. Yes.
So, first of all, what is the nearest 100? Nearest 1 10th power. Nearest 10th power is 100. Okay. And how much is falling short? It is 22, isn't it? These numbers are required. This 100 you don't have to write. This 22 is written. And while dividing this whole thing by 100, what will be my quotient and remainder?
Yes.
123 will be my quotient and 25 will be remainder. Now, for each of these parts, 10,000, 1,000 and so on, there will be 22 that is falling short. So 22 will be adding extra somewhere. Okay, this part. So because of this 1, it is in 10,000 position. The 1 in this one. There will be 22. This because of this 10,000, there will be 22 times in this digit. Next 1,000, and in fact 22.
Goutham ji. The question is only how do you separate quotient and remainder?
Oh,
which you have already done here.
Yeah. Oh,
you will 1, 2, 3 /45. 45.
Nearest 100. So just imagine that you are dividing by 100. Obviously, it will be obvious. So that line is put there. There is no change in the digits because it is through tens power.
So some people could not answer. Why? I didn't know. Okay.
Oh.
You want to complete the solution of this? Okay. Please complete it.
So now what is the next step? So there was already this in the thousands, there was 2000. And now because of this contribution, extra contribution from this one, another 2000 contributes. So total is 4000. This 4 is there and 4 will be multiplied to this one. So it becomes 88. It will be bigger because it is 78 quite far. Again, it will be. There are some error committed here because this went to the remainder. So finally, that error gets made up. 3 plus 2, 5 plus 13. You have to. It will be quite big actually. 13 you have to multiply. Then actually this one, this will come 13 into this. It will be quite big actually. It takes time. So therefore, I had given small examples. So you can see the examples. Similar things are there. This one, for example. This one. Any other doubt?
First, whether these people have understood, got it
Namaste,
clarified?
sir.
Go ahead.
Namaste. Sir, please tell me the division, how you will putting the steps in simple words. Like the previous one, 1, 2, 3, 4, 5 number, divided by 78. That one is reminder that base of 100 it's 22. You are multiplying first step with 1 because 1, 2, 3, 4, 5 are there.
Right.
Please tell me the steps because with the big numbers, the steps are most important. How you are adding and how you are multiplying.
Yeah.
That is required. Please.
Achha. Okay, so first you did this one, 22 you put here. Okay.
Yes, sir. Yes.
This 2 plus 2 becomes 4.
Yes, sir.
Okay. Now
Yes.
this 4, because this 4 I multiplied by 22. It becomes 88. Okay. Now it becomes 13 total.
So now we have to add 3 to 8.
Huh?
Now we have to add
3 to 8, so it is 13.
And multiply with 22.
22, yes. So 22 into 13 is actually
Royare, Royare.
286. Okay. Now this 286. 28 will put here and 6 will put here. This everything came to the everything came to the remainder side, because we have exhausted all these possibilities of here. First, this came here, next it is coming here. Gradually, it is receding towards right, means towards remainder side. Now you add finally. Now this 28 plus 36 plus 4 is 40. 40 plus this one, 41. And this is 13, 3. And this is 5. This is 1. Okay.
Okay.
Now 153 became the quotient and 411 my remainder. But remainder is more than this. So again I do this 411 by 78. Here is my division. It is I am again dividing by 100. So this is my line. Now this was again 22 was as for falling short. Now this 4 into this 22 will be 88. So 4 and 99. So again 99. So 99 actually cannot happen. So it is there's no division, simply you have subtraction. So this again contribute 1 more, 121. So this finally, this 4 came from here and 1 came from here. So you got 158. Finally 158 and 21. Okay. Is it too lengthy to cumbersome?
No, why are you putting 28 under the 8 directly? Means not like under 8 to the
Towards the
last
quotient. No. It cannot go towards quotient side. This cannot quotient, cannot go towards quotient side.
Always we have to keep towards right side, no?
Actually, there are more examples where you can see that they'll be tricky actually. They'll be tricky that it will be tricky. I was looking at that. So this part, please capture it. This part again, should I revise? That
it is clear.
First, by virtue of this 1, you multiply by 1. So 10,000 contribution is 22. Because of this, earlier there was already a 2. Another 2 is contributed from this one, from the 10,000 digit. 2 plus 2 becomes 4, and 4 into 22 is 88.
88.
Okay. And now again, this becomes 13. That contribution from the 100 digits is 13. That 13 times 22 will be contributed and contributed towards the remainder side now. And there are some errors while doing so, and that error finally gets made up here. I have seen that algebraic error actually in this. This procedure is very good. Procedure is very easy, so it doesn't take care of the intermediate errors. So this already get made up, and then this gets added. Total becomes 411, and this becomes added to 153. But 153% and 411 remainder 411, since it is bigger than 78, means the divisor, it has to again be divided. So we can divide it in any method, but this also you can do. And then again it comes to be 4 and 99. 99 you cannot do by this method because it is less than 100. So simply divide that 99. If 99 remainder had been there, so one more will go. So one will go, and then 21 actually remainder. The 21 remainder will remain 6, and then all the different intermediate stage remainders, quotients you add. This quotient 4 came here, and again because 99 again one quotient came. So total quotient becomes this 158, and then 21 is the final. Okay. One more example.
Yes, please.
Sir, here that the place here is displaying now 789 being divided division of 5 by 5013, the last step.
Oh,
That
okay.
is 211. Maybe something is wrong, or I'm not following that one. The last one.
Oh, yeah, 1055.
5013 divided by 789.
You mean to say some alignment problem or something like that? No. Because it is in the last digits of quotient, so everything will come towards remainder.
Okay. One get it out of it.
Here actually see there are invisible zeros here. We do not put that. Actually, it is from this step should be 100. Actually, it is 100. 100 coming to the remainder side. Here it is 440, mind it. So we are writing style is that we do not write these zeros.
What
But
is
it is not 21 quotient and 1 remainder. No, it is 100 as remainder. Here it is 8 quotient and 440 as remainder. Because this 211 is contributing. But this is the procedure. Don't have to always think that logically I'm always thinking that this because of this 10,000 there is a 221 is again contributed towards quotient and 100 as remainder. Not always you have to think. You have to do this procedure is like this. Only thing you have to know that logic behind all these things. The two cannot come this side. Here is 21 itself, 2100 to 2110 is towards remainder side. So they added to this. Again, you do like this. 739 and 739 because it's 79, so it is less than this 153. This 150 plus 3, and here it is. Here it becomes more, so they have to do 3 steps. Basically, this is step number 1. This is another step number 2. This is the step number 1. This is 2, and this is 3 steps.
in step number 1?
Unless this remainder becomes, please.
Please explain that 3587 how it will come, sir.
Which one?
The first one means 231 456 divisible by this one 789. In that 42 2 is correct, and 14 17 I can understand. What is the third step? 3587. How it?
3587.
Yeah.
See, here it is 231 456. So 2 multiplied by this comes to 420.
420.
And this 3 plus 4 is 7. So 7 into 211 is 1477. But 14 actually is lying below this. You have to see that.
That's what. Yes, sir. Yes. So
14 plus
to
2, 16 plus 1, 17. 17
So
multiplied by,
17. Okay.
this is 17 into
Mm. Okay, sir.
211.
Okay, okay, okay.
17 into 211 becomes 3587.
Oh, thank
And
you,
then
sir.
it's added. Actually, this is 200. This is
No, that is okay. That is
773.
okay.
And this is 3587. If I add all these numbers, we become 5013.
Oh,
Now, because it is 14 here, it doesn't matter. While I am adding this, I can add 2 plus 1 plus say 7 and this 3 plus 4 plus 1. Because in any case, that's 14. That one actually belongs to this one. While considering the quotient. But
okay.
while considering that contribution for this one, it becomes 14 here, not 4 just.
Means always keep the right side.
Always keep the
Right side. Means under 2, 14 comes. Means
under
we are
240 comes, but
yeah.
while I'm adding this total thing, it is all the same. I'm adding towards the 14 or I put the 1 in this side, doesn't matter.
Yeah, that's okay. Okay.
Ah.
Thank you, sir.
Any more? This division actually becomes the division becomes more and more complicated when this becomes away from the tens power. Therefore, I told that Vedic the state division, which will be the next course, next level course, state division is the best for this one. Otherwise, there are other ways.
And base is changing now. Means like a 500 we will take sometimes like a 200 and all. We are multiplying that one.
There are some cases where there some techniques are used, like this one.
Yes, yes.
There are you always think like that. So this about this 600, there are another way. I can double it, and double it, it becomes 1200 something, and then I can follow the other method.
Okay.
So I did, sometimes I tried also, but it will be time consuming.
Okay, sir. Thank you.
Here, this was understood, no? How it came actually.
No, why 91 minus 3 into 23? The remainder here is subtracted from less than 92. That's why.
Yeah. Because actually I wanted to divide by 23, but I while dividing by 92, this becomes 10 becomes my quotient and 91 remainders. Okay.
Okay.
So obviously something I'm dividing by 23. If I divide by I'm dividing by 92. Instead of that, because each 92 there are 4 of these 23 goes. So therefore, if there are 10 numbers of 92s, so obviously there will be 40 numbers of 23. That is the thing. About the quotient, that is multiplied by 4 is okay. But 91 remains my remainder. But 91 cannot be remainder for 23 divisor. It was fine for 92, but it was not for 23. So I have to see that how many 23 fits within 91. So there were 3 numbers of 3 numbers of 23 fits in 91 and remainder becomes 20. So that is the final. Another 3 contributes from there. This 20, this becomes 3 plus 3. Clear?
Yes, sir. Thank you.
Because 91 is 2 digit again. I cannot do something like that. I cannot do again like this something, because there is nothing I can do like this. The 23. So it's simply this divided by normal procedure. Okay, it's a normal division. So if I suppose your conventional division, somebody gets like this. Okay.
Okay. Yes, sir.
What do you do? I do 3 and 69, isn't it?
Important.
I do like this. So here it is a conventional division, like this. Because here same number of digits, so this by Nikilam division doesn't hold good. Clear?
Yes, sir.
Paravarta method. It is the other way around. Here I have to see that it is extra more than 100. So again, the division line I put the same way. I keep some space because this actually is a vinculum. I could have written like this. If you like, you can do like this also. Instead of this my minus symbol here, you can put it on the top. Doesn't matter. You have to only see that it is negative. So you can better not do this. Do this only. It will be clear. 2 minus 1 is again 1. Again it becomes minus 1 minus 2. Add all these. Here it becomes 1, 2, 3, 1 and 2, 3, and this 3 minus 2 is 4. So 3 minus 1 is 2, and multiply by 2 is 6, minus 2 minus 4 minus 6. And here there is a trick actually. Oh, I didn't explain it here. 12 and minus 20. Minus 20 was my remainder. So minus 20 remainder means, so it became like that. 12 into 1, 1, 2, 3 minus 20. Is equal to 1, 3, 4, 5, 6. So if I cross that limit, 12 into 1 on 23 actually cross over this, and it is more than this. So better to do 11 into 1, 1, 2, 3. This is the remainder. We always expect remainder to be okay. This 1123 minus 20 is 1103. This, so one of the 1123 we throw towards remainder side. It becomes 1103. So this becomes the same number. Clear?
Yes, sir.
Negative in remainder means actually you have to subtract from the divisor. Okay. So and subtract 1 from the quotient. Here it becomes finally, see here, the interesting that finally it becomes 0. And this becomes positive because this 3 minus 4 is minus 1. And minus 1 into minus 2 minus 3 2, 3 becomes 23. And again 4 minus 6 plus 2 is 0. So it becomes 0, 0. And we finally add. And again 2 minus 1 is 190, 19. Vinculum, you know.
Yeah.
Here there is another way is followed. It is different. It is actually in Nikilam method, if we do like this, the 8 actually is very big that way. So what we do? We do like this. 1, 2 and minus 2. And then the same. Because I'm writing that I could have written this Nikilam method, I could have done like this. multiplied by 4. Isn't it?
Yes.
This comes straight away. But sometimes this technique is given because this becomes 481. This technique is given this way because sometimes what happens, we do not like to work with bigger than 5 numbers, as I told. So you convert it into vinculam. And result becomes like this. This is also same thing. Here also you simply can do like this. But vinculum you can always convert the more than 5 digits to vinculum, and then you can work. The technique is given. So here it is quite small and simple. So this also works. But time may come when suppose there are multiple steps, and there will be more difficulty with these big numbers. Then it will be easier to handle with smaller numbers with vinculum. That is just a way was given here. Clear?
Yes, sir. In this one, sir,
Yeah.
1,699 divided by 223, you taken off 223 divided by 2, then it is 111 and half.
Yeah.
That first 2 steps, the up to end, it's okay, sir. That's the quotient is 7.5 and remainder is 2.5 and 1.5. Okay, that quotient is 7 and the remaining R is equal to remainder is equal to 111.5. That one I cannot. Last step. Plus 25 plus 1.5.
Yes. Because see, the half in quotient means that actually what I'm meaning 7.5 multiplied by this my 223. After dividing by 2, up to here there is a division by 111. As if I am dividing by 111. And I came to that 15 should have been my quotient, 111 and a half. So dividing by 111 and a half, this number, I would have gotten I got 15 as my quotient, and this much 2.5 and 1.5. This also has a meaning. 25. This actually it becomes 25 and 26 and a half. Basically, it's 26 and a half. Now, but that is fine, 26 and a half. But 15 was my quotient. But actually, I wanted to divide by 223. So my obviously that quotient will become half, 7.5. But 7.5 means what actually? So 7 times of 23 and half times of 23. Half times of 23 means what? Again, this.
Okay.
Half times of 23 is 111 and a half. So that 111 and a half is continued.
Okay.
And again, this I told this is 2.5 means 10th digit means 25, and this plus this half, 1.5, and so therefore total becomes 138. These are different techniques actually.
Yeah.
So, any more questions on this one? And please tell your questions further.
Okay.
Someone has had some question in the divisibility. These I just wanted to show. These are not how lengthy it becomes actually the recurring decimal. I wanted to show through either in conventional method or this Nicola method. Both will be very big actually.
Okay, next one is next question
Ah,
is the oscillator for 23 is
Huh?
the oscillator
oh, oscillator. Oh,
for 23.
tell me. Okay, I will use this one. 23.
Yeah.
So actually, that time I discussed. Actually, there are some participants also who suggested that it's a good one. Actually, if something is ending in 3, always you multiply by 3, so that it becomes 9. 69. Okay. So oscillator becomes, it is 70 minus 1. So this 7. The positive oscillator and 7. Or plus 7. Okay.
Anybody
Understood?
has doubts? Anybody has doubt in this oscillator?
Say for example, 7. I can do 2 ways. If we get something 7, you multiply by 7, it ends in 9. Up to somehow it will end in 9. Or there is another way. If we get a smallest oscillator, multiply 7 by 3. It can be 7, it can be 17, it can be anything ending 37, 27, and so on. Becomes 21. So here it is. This is 50 minus 1. And this is 20 plus 1. So here the oscillator becomes oscillator becomes is the opposite of that. It is plus 5. This 5. And this is 2. It is because it is my plus, it is opposite one. It is a minus. So I can use either plus 5 or minus 2 in case of 7.
What does oscillator itself mean?
Oscillator actually is the one which you keep multiplying to the unit digit. The oscillation process it is called. I'll tell you, and the example is given here. You tell me any number by, I want to divide by, to test by 7. Say dividing by 7. And you give any number?
321.
320. So I want to divide it by, test the divisibility by 7. So 7 as oscillator either 5 plus 5 or minus 2. So let us first try plus 5. What I will do, I will separate it to the unit digit. So it becomes 32. And then I multiply this unit digit with the oscillator. Or I could have done.
It means the components of 7 and 5, is it? You're taking it as 5 and 2 are the components that form 7 and 5. You're assuming that way and starting off as it.
5 and 2, 5 and minus 2.
5, why minus 2? How did you
Minus
get?
2.
7 and 7 is made up of two numbers, 5 and 2. Is that how you're looking at it?
That
Why did
actually
you
happens. This actually happens. Positive and negative oscillator, when minimum positive and minimum negative oscillator, if they are added, they will be same as the divisor. When testing that testing divisor. So here it becomes how much? 37.
And the question is how you got 5 and -2.
Yes. Why 5 and -2?
He just
How did-
explained in the previous slide.
It was previous slide I told, no? That time.
Again, can you explain that?
Yeah, I will explain here. See, for 7, I can, if I multiply by 7 or I multiply it by 3, in both cases, it becomes near to some tens power. I mean, tens multiple, not power. Okay.
Okay.
The 49 is actually, it is 50 minus 1. 49 is 50 minus
Okay.
1.
Or 21 is 20 plus 1.
It is 20 plus 1.
Okay.
So I can use the oscillator 5 and -2 because this actually this opposite of this sign. But what I can see that 49 that way better to do like this without any confusion. 49 plus 1 is 50 and 21 minus 1 is equal to 20 to arrive at the nearest tens multiple.
Okay.
So here it becomes my this plus 5 because this was plus, so it is plus 5 or this is minus. Both can be oscillator of 7.
Okay. I think this requires some visual understanding. And
Just practice. You just clear idea that what is what, when to do plus and minus. It is a this one. If we express like this, it is. If we express like this, it is the opposite of the sign. This is the opposite
I
of.
have one doubt, sir.
Huh?
So oscillator means we have to multiply those numbers which are nearest to 10. That's it. No, we cannot go for 7 into 4 or 7 into 9.
No. Have to arrive to nearest to 10. Either 9 ending in 9 or ending in 1. Either ending in 9 or ending in 1.
So we have to multiply, like if we go for a number 8 into, we have to do something which ends with in units place, it must be ending with 9 or 1.
Oh, no, not 8. So divisibility by 8 actually is something else. 8 is actually 2's power, and then it is say last 3 digits will be divisible by 8. There are different formulas. These are the oscillation process is valid only for numbers, divisors ending in 1, 3, 7, and 9. You remember these 4 numbers. 1, 3, 7, and 9. These 4 things are there, even
So
not
we
5.
have to take oscillators for only these numbers, not any other numbers.
Divisibility test oscillation process, divisibility by oscillation process is valid only for this number. Ending in 1, 3, 7, or 9.
Okay.
Because any odd number I've given it here, no? See, divisibility.
Okay.
Divisibility rules. The numbers 2 and 5 being the factor of 10, we have similarity in this, and 2 and 5. Divisible by 2 to the power n. Any powers of 2 requires last n digits to be divisible by 2 to the power n. For example, this is divisible by 4 because this 56 is divisible by 4. Something is suppose say suppose 700, 128. Okay. This is divisible by 8 because this 128 is divisible by 8 because last 3 digits. Similarly here, 5 to the power n is divisible by this
Odd numbers, sir. We can say like odd numbers and even numbers. Like divisibility by 2, you are getting like units place 6. 1,
yeah.
only
No,
odd numbers can be.
divisibility by some power of 2 and divisibility by composite number. The composite number in the sense that not composite but not power of 2 or 5. This has a different formula that it has to be divisible by its component of 2, 5 or things and then other this 379, 1379, this part. And then divisibility by 1379, this has a general method called osculation. Only divisible by numbers ending in 1, 3, 7 and 9. Doesn't fall under these 2 categories. Then only we are using osculation. Okay.
Okay, sir.
And in the childhood in the school, this 3, 9 and 11 are taught, but they do not mention the process called osculation. But here also the same thing actually, osculation actually comes because it is oscillator is +1 for these 2 and -1 for this one because it is 10 minus 1. 3 into 3 is 9 again. So 10 minus 1 is this one, and 10 plus 1 is this 11. So the oscillator becomes +1 and -1. So it is becomes so obvious that we do not do this. Suppose I have to see the divisibility of say suppose 343. 342 will do by while divisible by 9 or not. What will do? We know that we add, but suppose I do osculation, what happens? It becomes 34 plus 2. 36. Means that 2 into 1. 1 is the oscillator. Again, I do same osculation process. 3 plus 6 into 1. So equal to 9. This I'll do. So instead of doing every time doing separately by into 1, we what to do? We directly straight away we add all these numbers. It's the same thing actually. So oscillator is 1. We do not we do not look at it. We just straight away add all these things. Similarly, for suppose some numbers you are getting. We want to see that whether it is divisible by 11 or not. So what we'll do is 3, 4, 6.
18.
Okay.
And just add the alternative numbers. And
Alternate
see whether
numbers. So minus
equal.
5.
3 plus 6 and 4 plus 5. Both are 9.
This becomes oscillator is -1. So it becomes 341. Again from 341, we do 3, 4 minus 1 is equal to 33. Basically, so therefore, see, you are alternately we are doing negative of that. So again 3 minus 3, 3 from this one again I do 3 minus 3, which is 0. So if I say that it is either 0 or 11, it becomes divisible by 11. So instead of doing like this, so straight away we do alternative numbers. We do like this one: 3 plus 6 and 4 plus 5. So actually we are
deducting like the 3, 4, 6, 5.
we are using oscillator. We are using oscillator -1. So in that using oscillator -1 takes that form or alternative sum. Okay. So therefore I told that becomes divisibility by this one becomes we use oscillator but it never did mention that word osculation. But for others one, therefore actually, since we didn't know about oscillation, we skip divisibility by 7. There is no reason why we skip in the school days divisibility by 7 or 13 or so on. It is so easy. It should have come directly. Okay. This was my point.
We never learned the word oscillation, I think, in school.
Oh,
I didn't learn.
And therefore we skip divisibility by 7. Okay. Oh, I'm going on the opposite. I was here. Actually, as I told that there are this first two categories, anything as 1379, you have to follow the oscillation. And then suppose you get something, suppose by divisibility by say 92. Okay. So 92. So this is divisibility by 23 and 4. 97 is 92 is there. Whether something is divisible by 92 or not. So I have to take the component. It is 23 into 4. So divisibility by 4 will come by this method. Last two digits divisible by 4. And divisible by 23 will come. You get a number which is obviously it will be even. So divisible by 23, you get that oscillator 7 and you process. Both the combine, you can say that is divisible by 90. Clear? Isn't it? Or should I repeat?
Please repeat. From the question, starting with the question.
Suppose you get a number like this. So let me find out a number which is divisible by 92 first. When otherwise it will be non-divisible. I directly state what I can do. A small number, say 8188. But if we get divisible, finally you get a good feeling. Otherwise, I want to test whether this 8188 is divisible by 92. This 92 has two components. One comprising purely, one purely comprising of 2, 3, and another will be powers of 2. Had that been power of 2 and 5 both, so obviously you will get a 0 somewhere. So you cut that 0 because the 0 doesn't matter whether you add multiply or not, it will be divisible.
Sir, one doubt, sir. See, for 8188, you are asking whether this 92 is divisible or not.
When this is divisible by 92 or not?
Yeah, for this, it's we can see like this. No, in units place it is 8, and in 92, its units place is 2. Both are even numbers, so they are divisible. If you go for 91, it is not divisible.
No, say for example, this 8188, but some 8190. So it is also our even number, but it cannot be divisible by 92.
No, sir. Say the number is 8188 only. And you are seeing whether it is divisible by 93 or not. It is not divisible by 93, as in 93, 3 is in units place where it is an odd number, and here it is even number. So it is not divisible.
You mean to say something ending in 8 cannot be divisible by 93?
No, sir. When a number, when we want to see whether it is divisible by other number or not, just we have to see whether it is even or odd. Evenly means we can find it out directly without any calculations only, no? Like here,
You could
the
have
number.
reminders, right?
Yes, ma'am.
You could still have reminders even if it is even number, no?
Mm-hmm.
Yeah, but See, in this case, 8188 is, where we have to find out whether it is divisible by 92. So the number is exactly divisible by 92 because here 8 and 2 are even numbers. We'll get 89 with a 0 as a reminder. Means this is what we were learning from school age, whether how to see the whether number is first divisible by 9.
Even and odd numbers, you mean, right?
Yes, this is in units place. It is even, and when we get both even numbers,
No.
it is divisible.
An odd number is never divisible by an even number. Okay. But
No.
other
Therefore, you just tell me for the case of 8188 is divisible for 93 or
first
not?
let me complete, I'll tell you.
Yeah.
See here 8188. So we see that 88 is divisible by 4. So one part is there. This is right. Okay. Now you have to see that whether it is divisible by 23. For 23, this oscillator is 7. Okay. Oscillator is 7 because 23 into 3 is 69. 69 and it is 70 minus 1. So oscillator is 7. So what do you do? It becomes 818 plus 8 into 7. Please calculate it. Okay. Chop on that. 15. Am I correct? It's okay. Again, it becomes 87 plus 4 into 7. 5. And again, I can do
46.
46. So 46 is divisible by 23. Again, if I want to do again this thing same, again it returns to 46. So 46 will remain as 46. So 46 is divisible by 23. So it is divisible by 23, divisible by 4. So therefore, it is divisible by 90. Is clear? How it is done? So this is our
Yes.
composite number. So a composite number will either have a it is something ending in 1379. Even those things are composite or don't have to see. You have to just oscillate that you can comply. You can just calculate the oscillator. It is not that it is something powers of 7, powers of 3 separately. It will. You need not do. You can do it, but you need not actually.
Maybe this is the reason why in childhood they used to tell by heart the tables when we were small, so that you could visualize the components that formed it, I think.
Yeah. Any doubt?
So the skill here is only to find out the oscillator first.
Yeah.
Right.
Still you till you find something, some more example, anybody has in mind?
Sorry to ask you, sir, other than this, I just want to know a number to be converted into vinculum and vinculum to be converted in number. Means I know some procedure, but your procedure, it's bit easy for me. So I just want to clear that. How means less than 5, you were telling whatever the numbers which are greater than 5, you have to.
Yeah.
So just that one, I just want to know.
Want to repeat that one?
Yes, sir, any number which is we have to convert into vinculum with more than 5, number which has got more than any number, sir. 1, 8. This is 10 minus 8 is 2, and that number should be added to the left hand
No,
side.
20 minus 2 actually. 20 minus 2
Yeah,
is
2 vinculum. Okay. If it is 7, 8, 3, 4, 2.
These are last 3 digits are smaller than this thing. So
Okay.
this is
Then
actually.
Sir, I will tell this one, sir. Just correct me. From here it is 3, 4, 2. You have to write like that only. In case of 8, it must be vinculum 2, and we have to add one number to 7, right?
Right, you're right.
Achha, we have to add when for the numbers. Okay.
We always have to think like this one. Only this part.
Okay, all from 9. All from 9. So if
70
the
plus
number
8 and same as 80 minus 70 plus 8 is same as 80 minus 2. That's all.
okay. And if there is any 0 in between, like 7, 0, 8, 4, 1.
708.
8. Yeah.
Then
4,
what will follow it?
7, 0, 8, 4, 9.
Oh, 4, 9.
Yeah. Here for 9, it is minus vinculum. So we have to take numbers from left to right or right to left. How we have to go with that?
No, this 4, 9 becomes 5 and 1.
This is how this is. This is vinculum, this one, and you are adding this. So 5 must be like that only. This is 2 vinculum, and we have to add 1. Okay. Here it will be 1. So 7 also we have to do, no, sir? It is also more than 5.
Yeah. 7.
So
I'm sorry. Actually, here I didn't keep it. When this one, actually you have to do 1, 2, 2. Yes, that's what you demanded me. 7 of the. This is the first step we can do. Therefore, next step we can do this one.
Yeah, 7 will be becoming 8. So 2 vinculum, and here we have to add 0 or 1 here. If we come from right to left, it will be more easy, no? All from 9 and last from 10.
Okay.
How, sir? So in this number 70849, 9 will be vinculum 1. In the number 70849, 9 will be vinculum 1, and 1 will be added to 4, that is 5. And this 8 will be vinculum 2, and 1 will be added to 0, that will be 1. And 7 will be vinculum 3, and 1 will be added extra one. So 1 vinculum 3, 1 vinculum
Oh,
2.
no. I did the opposite. Oh, 9, it cannot have.
Yeah, 1 vinculum 3 it
9.
will be, no?
Oh, 9 cannot be. What are you saying?
Sir, here 9 will be vinculum 1, no?
9 will be vinculum 1, huh?
Yeah, and 1 will be added to 4. That will be, it will become 5. So we need not do any vinculum for 5.
Which one?
Yeah, this is what even I got. Okay.
How, sir? How it is?
10 minus 7 is 3. So the 1 goes forward. and then-
No, sir. As per our formula, it is all from 9, last from 10. No, so we have to do it from right to left, right? So how I
No,
did
actually, see, I'll tell you. So 7, 0,
It is
8.
always easier from right to left only, sir. That
yes.
Yeah, right to left.
Okay.
70849. 10 minus 9 is 1. Then the 1 gets added. Oh,
There
9
are-
minus
there
4
are
is
these
5.
components. There are here, this more than 5 comes like this. So there are blocks actually, more than 5 blocks actually. Ultimately, this ending with a less than 5. Okay. So this becomes 1, 3, like this. And this becomes 1 and 2 vinculum. And 5 and 1.
One.
So when a number is
Yeah, I was doing the opposite way, and actually my intention
No.
was, intention cannot be like 9 should be there. So
means even I
this
got
was
the
okay. Logically, it was okay. 9 vinculum, but 9 vinculum should not happen because already it is less than 1, less than 5. So you do not do. Suppose somebody wants to do it forcefully, then it could have become that thing.
Okay. So
Can you go systematically and convert this 1 minus 3, 1 minus 2, 5 minus 1 to 07849?
Yeah,
The
actually,
reverse.
when we do from vinculum to number, how you that is a procedure. Like if you find the number, vinculum is 1, vinculum 3, 1, vinculum 2, 5, vinculum 1. Convert this into a number. How to do that?
The last one, last digit you add.
This is always this is becoming the last one always. No, I can give another example.
No, Mahodaya, you just reverse this number 1 vinculum 3, 1 vinculum 2, 5 vinculum 1 to
Yes,
its original number.
Original number.
Yeah, it will come. It will come.
If this will see divide. This is subtracted from 10, becomes 7, and this is has to be
Yes.
reduced to
Correct.
reduced to 1.
Zero.
Becomes 1 becomes 0.
Yes, correct.
So it's nothing but
That's right.
vinculum 1 means 10 minus 1, it's 9. And 5 means 9 minus 5, it's 4. Here, vinculum 2 means 9 minus. This is
No,
vinculum
10
2 means
10
8
minus
only,
2.
no?
10 minus 2, 8.
He has made it into blocks of 2. So it is 10 and 9, 10 and 9 alternated.
I can give another number. From this one itself, how do you do? Suppose I give another number. Okay. I only double that. Now you tell me. how it happens.
So here, last number is 9. So 10 minus 9 is 1. And you'll add one number. Then
So
again,
here, see, these are the blocks you have to create like this. See, as soon as you get something less than 5, before that you put a block. Less than 5, put a block. So this becomes
Not
how
2,
much?
sir.
This becomes
Can
5.
understand.
0.
Okay. This becomes how much?
Excuse me, sir.
Hmm.
How it is less than 5? I do not understand. 088.
No. 0 is less than 5. 4 is
No,
less
no.
than 5.
Actually, the concept is not being understood. Concept should be understood. Then automatically the doubts will get clarified.
Yeah. What is that?
yes, sir, I got the same answer. But the sir, how I am doing it is, it's all from 9 and last with 10. That last one 9 is there. 10 minus 9 is vinculum 1. But here the one when you add for 9, it will be 10. So 9 minus 10, how it can be 0?
No,
Let's say you take 499, then it will be 500 minus 1.
No. Means why you are taking it so complicated when we have to do with a single number, it will be easy. Then you'll get this answer.
Yeah, correct. Last digit from 10. So 10 minus 9 is 1.
Yes.
And second thing is 9. 9 minus 9 is 0.
Yes.
The third one is 9 minus 4 is 5.
Yes.
5.
We can write 501. That vinculum. Why that negative signs are to be given?
No. This is 50. Vinculum 1 is okay. And for 8, it is again you
No,
have
this
to
is-
go for 10. Again, you have to see from
Yeah,
10 minus
that
8.
gives the confusion. Here also 8, 9 minus 8, 1 we can write.
Yes.
Single
and-
step, this whole number can be written like that.
No, sir. Now you have to see from 10 minus 9 is 1. That is vinculum 1. Here it will be, we have to add 1 to another 9, which is in 10's place. So that is, it will be 0, 10 minus, and this 4, 1 will be added to this 4 according to our formula. Then it will be 5. Then means it is 4 plus 1 is 5. When it comes to 8, we have to see again from 10. 10 minus 8. Is that, sir, Goutham, sir?
Yeah, actually,
No,
this is
that-
Nikilam Navata Charamam Dasata. Other numbers, this
But please
is
explain
subtracted
from
from.
fundamental one number. That will be sufficient, I think.
Yeah. With one number only, it will be easy. Instead of
No,
rounding up
but
this
in practical case, you can have more than one number.
But when you're reversing this, how would you know you have done it into blocks like this? Can you reverse this number, sir? Can you reverse this 1 vinculum, 2 vinculum, 3, 1 vinculum, 1 vinculum, 2, 5, 0, 1 vinculum? How do you reverse it back to 770, 8849?
Again, you
At
do
the last digits you
Nikilam
can.
Navata Charamam Dasata. Again, 10 minus 3 is 7. 9 minus 2 is 7. And then
This last one.
here you
How do you
subtract 1.
presume?
Subtract 1. Here also 10 minus 8 is 10 minus 2 is 8. 9 minus 1 is 8. And then 1 minus.
No, how do you assume there are blocks at all? If you look at it from the answer, you don't know you have divided into blocks at all. So in normal course, you'll do 10 minus
Blocks,
10
block,
minus 1 is 9. 9 minus 9 is 0. 9 minus 5 is 4. 9 minus 2, you will look at it like that. How will you know it is 10 minus 2? Because you don't know about the blocks when you got only the answer.
blocks, we get blocks because you see that vinculum and non-vinculum.
So the
There is
question will
another-
show
another
the blocks, is it?
Huh?
The question should show the blocks then.
Yes,
No,
in
ma'am.
the vinculum, in the end of vinculum will be blocks.
Yeah,
No,
in the
no,
vinculum
sir.
part of the thing, you should get the blocks. Only then you can convert it.
Yes.
No, this is in even means you are having 1, 2, 3, 4. So only you can divide into blocks. But when the number will be in other condition, you cannot divide them into blocks. No. See, easiest method is you can just convert vinculum to number. I feel ki this is vinculum 1 is 9. 10 minus 9 is 1. Same thing, reverse procedure.
No. My question is, if there are no blocks in the
No,
vinculum part of the
blocks,
answer,
sir is asking to assume that let it be blocks. But without blocks only we have to do, because blocks will not be given in any other number. They'll just give us the number. That's it.
No, blocks.
then you can't do
this
it.
concept of blocks, I did bring like that because I
You
told
can't
that
otherwise assume. No, how
vinculum,
will you assume that it is 10
vinculum
minus 1
adds only, vinculum
is only for that?
only for that which is more than 5. More than 5 and less than 5 blocks. And similarly, when I find an expression which is more than 5 all the time, so there I can get I can get vinculum and non-vinculum. There I can identify blocks easily like this.
Now you can just try without blocks also. We can get answer.
This won't be the answer then, no?
No, this is the answer.
Blocks.
Let me tell you. Let me explain.
Okay,
it.
okay.
No,
Tell
blocks.
me without the blocks.
Yeah,
Without the blocks, how will you reverse?
Without the blocks only. If
Okay,
you
10
don't
minus.
consider-
Okay, I will tell you now.
These blocks
Yeah.
actually I introduce only to
Yeah, sir has introduced, but
make
this is not.
you don't have to write blocks like this, but you only mean to say in order to know that Nikhilam Navadas Taramam Dasata,
Yes.
okay, up to when we subtract from 10 and subtract from 9.
Yes.
understand
Otherwise,
that thing,
without the
I-
blocks, you can't understand when to subtract from 9 and from 10.
Exactly. Huh. But this is
You can do it
No,
directly.
okay, I will show you here. 10 minus 1 is 9. 9
Yes.
minus 9 is 0. 9 minus 5 is 4. Then you should only continue with 9.
No,
9 minus
here-
Once it is
Here,
crossing 5.
it is not 9 minus 4 yet. I'll tell you. This is suppose it is 3. Suppose this is 3. For how much it will be?
4.
Not
That
9
will
minus-
be,
No,
Yes,
it is
four.
not.
yeah, it is 4.
4. It we
This
have to
one
add.
more than this one. The one
Yes.
more than this. That is by consideration it becomes 4 and 5, but it's not actually. Okay.
And for 8, it is already it's more than 5. So 10 minus, again, you have to follow the same.
Oh, okay.
Nikhilam
10 minus 8, and we have to add either 9, then minus, that is vinculum 1. And again, we have to add 1 here. So it will be 1 for 0. And here again, same
Okay.
method, 10 minus 3.
Understood.
10 minus
Okay,
7. For
shall we
each
close,
number, if you take, it will be easy.
Goutham ji,
Huh?
shall we close and start the exam?
Yeah, it's time now. Yes. This is clear finally or not?
Yeah, we have understood, I think.
Yeah,
Mostly.
Dhanyavad.
Confirmation.
Dhanyavad, sir. Dhanyavad.
Thank you. Thank you for the extra time
Right.
you have taken and
Thank you.
explained us patiently.
Very kind of you, sir. Thank you.
Namaskar.
Now I will take out the question paper.
Thank you, sir. Thank you.
Mukherjee sir, thank you, sir. Thank you very much.
Okay, thank you.
Can you take out this presentation?
I have taken out the presentation, no?
Okay. I still get it. Anyway, let me take out the question paper. I got the question paper. So there are 30 questions.
So you have given link in chat box?
Not yet. I'm trying to take out the question paper itself.
Sorry, okay.
1 minute. Now I'm going to put this in the chat box. Okay, I have put it in the chat box. All of you got it? Anybody who hasn't? There are 30 questions. And time given is 20 minutes. Don't worry about the serial numbers. The first few questions are serially with 400, remaining starting from 1. I put the question paper in WhatsApp group also, in case somebody finding problem. We will we'll do Vande Mataram. sorry, we will do Prarthana and Janganmana at 8:25.
నమస్కారం అండి.